Hello students, welcome to Educate. In the last class, we have discussed about the physical properties of aldehyde and ketone. Now, we will discuss about the chemical properties of aldehyde and the ketone. So, one question was asked in NEET examination in 2005 and again around 2010, that the aldehyde usually shows which types of chemical reaction. Number 1, nucleophilic addition reaction. Number 2, nucleophilic substitution reaction. Number 3, electrophilic addition reaction. And number 4, electrophilic substitution reaction. So, aldehyde and ketone both usually shows the nucleophilic addition reaction. How? Let's see here. So first one here about the nucleophilic addition reaction. How is that? You already know that the hybridization of this carbon atom is sp2 and this one also, this oxygen also sp2. Shape will be trigonal here, planar. Trigonal planar. If B is towards the observer and A is below to the observer, then the nucleophile will be on this plane. This B is perpendicular to this plane, which is in that direction, and A is perpendicular below to that plane. So nucleophile will approach toward this acylic carbon atom from this plane. Why? Because it goes on the structure. Carbon here, oxygen here. So between this carbon and the acylic carbon atom and this oxygen, sigma bond will be there and it is on this plane. So unhybridized p orbital will be perpendicular to this plane and perpendicular to this plane. If at this plane the other group has been added, then the p orbital is perpendicular to this plane. So electron cloud density will be perpendicular to the plane at which the carbon, this oxygen, the groups bonded to a acylic carbon atom will lie. So nucleophile will approach towards the oxygen here, that will approach from perpendicularly. The nucleophile will approach towards the acylic carbon atom perpendicularly. That's why here the nucleophile will approach towards the acylic carbon atom perpendicular to the plane at which the acylic carbon, the oxygen and the atoms or groups bonded to the acylic carbon atom. And then after, there will be bond formation between the nucleophile and the acylic carbon atom. So here there is bond formation between nucleophile and the acylic carbon atom, and after that this oxygen will pick any H plus ion from the solvent, or if that be the part of the reagent also. So then after this oxygen will pick the H plus ion. So one point you keep in the mind that the nucleophile will approach towards the acylic carbon atom perpendicularly to the plane at which the acylic carbon, the oxygen as well as the atoms or groups bonded to the acylic carbon atom will lie. Okay, so that's point right. In the 12th board examination, usually questions don't ask about to explain about this one, but the MCQ questions you should there is priority of asking these questions in the MCQ, so you should know about the concept directly. In the explanation based, this question will not ask, but you should have the knowledge so that you could solve the questions if that will ask in the MCQ of 12th board, in CUET, NEET, or in IIT main. So that is here. In IIT advanced, there is less chances of asking this question about this one. Okay, that is about that the nucleophile. So keep in the mind that the nucleophile will approach towards the carbon atom, acyclic carbon atom, perpendicular to the plane at which the carbon, that is acyclic carbon, the atoms or groups bonded to the acyclic carbon and the oxygen are situated. Next one is here that among aldehyde and ketone, usually aldehyde is more reactive than ketone. Towards the nucleophilic addition reaction, the aldehyde is more reactive than ketone because the aldehyde is more polar. Why? Because watch out here about this acyclic carbon here, and in aldehyde there is alkyl group and a hydrogen atom. How this molecule is polar? This molecule is polar. Why? In presence of reagent. In presence of reagent, the oxygen, this oxygen attracts the pi electron towards itself, and that there will be development of a completely negative charge on the oxygen and a positive charge on the carbon, and here hydrogen and here alkyl group. This one, in case of then after this alkyl group donates their electron to the acyclic carbon atom by the plus I effect. That is in case of aldehyde. What happened? This oxygen attract the electron towards this oxygen will attract the pi electron towards itself, and hence there will be development of a completely negative charge on the oxygen and a completely positive charge on the carbon, and then after this alkyl group donate their electron to the positively charged carbon atom by the plus I effect. In the same way, in ketone, in case of ketone, what happened? Same thing happened here, H or R, here H or R. In case of aldehyde, alkyl group donate their electron to the acyclic carbon by plus I effect. In case of aldehyde, so only one alkyl group is attached. So here polarity will decrease through less extent. While in case of ketone, the two alkyl group will donate their electron. So this one will be, ketone will be less polar, and in aldehyde that is more polar. So more polar, so nucleophile will attack towards the acyclic carbon atom more frequently. So that is here among aldehyde and ketone, aldehyde is more polar than ketone, and that's why the nucleophilic addition reaction in the aldehyde are easier compared to that of ketone. Okay. That is about this one. That's in the 12th board examination. Question may ask in the form of give a reason why nucleophilic addition reaction in aldehyde is easier compared to that of ketone. So you will have to write that since in aldehyde there is only one alkyl group, so by the plus R effect, plus I effect, it will not decrease the magnitude of positive charge on the acylic carbon atom as extently the 2 alkyl group in ketone decreases. Okay, and hence the aldehyde is more polar than ketone. That was, and their chance of asking the question is should not be ignored, but there is, that will ask. Now watch out about this question. Listen here, the question is benzaldehyde towards the nucleophilic addition reaction. Benzaldehyde will be more reactive or the propanol will be more reactive. That means benzene carbonaldehyde will be more reactive towards nucleophilic addition reaction, or the propanol will be more reactive towards nucleophilic addition reaction. So let's see here, in case of benzaldehyde, draw the structure here, benzaldehyde. So compare about the polarity in benzaldehyde and in propanol. So here benzaldehyde and propanol, this one. What happened in case of benzaldehyde? Actually, polarity will be, because this oxygen will attack here, positive charge. So in case of benzaldehyde, this pi electron will go toward this carbon atom. So here will be double bond formation. So there will be double bond formation here. Firstly, this one. So this negative, the positive charge on the hydrogen, on this carbon, positive charge on the carbon atom, that will diminish, and here positive charge. So in case of benzaldehyde, and then after there will be resonance. Resonance will continue. So in case of benzaldehyde, benzaldehyde is less polar due to here plus, here minus R effect. Here benzaldehyde is less polar due to minus R effect of phenyl group. Here minus R effect, and here in propanol, what happened? The oxygen will take the electron, so here negative charge, this carbon will have positive charge, and this positive charge will be satisfied, that means that will get try to neutralize by this alkyl group, that will be plus I effect. So in case of benzaldehyde, the magnitude of positive charge on the acylic carbon atom will be very less compared to that of in case of propanol, because in case of benzaldehyde the magnitude of positive charge will neutralized by the here minus R effect of the phenyl group, and in case of propanol the magnitude of positive charge will neutralize by the plus I effect of the ethyl group. As we know, plus R effect or minus R effect is more effective compared to that of here plus I effect of alkyl group. That's why propanol will be more reactive, that propanol will be more reactive towards nucleophilic addition reaction. Okay, so right here Clear here? This one, that's about which we have done. I have explained like that, written here. So in the reasoning based questions, what you will have to do, you do this one, so, and then after show the resonance, and then after that, since propanol is more polar than that of propanol, since propanol is more polar than that of benzaldehyde, because here it will neutralize the positive charge, neutralize on the acylic carbon atom by plus I effect in case of propanol, and by the minus R effect in case of benzaldehyde. Now let's see some nucleophilic addition reaction. Some nucleophilic addition reaction. So let's see here. As for example, let's see. As for here any aldehyde or the ketone, whatever be that, the same mechanism will apply here in case of aldehyde and the ketone when there will be nucleophilic addition reaction. So firstly, there is reaction with HCN. So that react with HCN, hydrogen cyanide. So what is here? This HCN, that will result plus here minus. So Cn minus will be, the Cn minus is the negative part. This oxygen here attach the electron, so here oxygen will have positive charge, carbon will have negative positive charge. So this carbon will attract toward this carbon atom. Why? Perpendicularly, the cyanide group will attract toward the acylic carbon atom perpendicularly to the plane at which the acylic carbon, the atoms or groups bonded to the acylic carbon atom and the oxygen lies. And then after this Cn, so there will be bond formation between carbon and this carbon, acylic carbon and the carbon of cyanide group. So that will be after that, this oxygen will pick any one of the H plus ion from the molecule. This oxygen will pick the H plus ion from the solvent, or if that was the part of the reagent. Okay, so that's compound here will be, so that will be this compound will be called cyanohydrin. Hydroxyl group is here and cyanide group is here. In this compound, there is hydroxyl group as well as this cyanide group. That's why this compound is called cyanohydrin. Cyanohydrin form. Okay. After that is reaction with NaHSO3. Let's see here in NaHSO3. This NaHSO3 that will dissociate into Na plus and HSO4 minus. So this oxygen will attack the pi electron towards itself. Here negative charge and here positive charge. So HSO3 minus, that will bond to this carbon. So SO3H, this one, HSO3 that will bond to this carbon atom, and the sodium, this one is the positive part. So this sodium will bond to this oxygen. So that's why this compound. Now there will be exchange of sodium and hydrogen between these two. So sodium then go to bond to there and hydrogen comes here. So that will come here. Bisulfite addition compound will be there and it will be crystalline solid. It will be a crystalline solid, this compound form. Okay, that is here. So when the aldehyde or the ketone, here may be one side R and here the side R or H. So NaHSO3 that dissociated to Na plus and HSO3 minus. So HSO3 minus has the negative charge. Here carbon have, acylic carbon will have the positive charge and the oxygen will have negative charge. So that's why sodium will get bond to this oxygen. Positively charged species will attract towards the negative charge and the negative charge species attract towards the positive charge. So HSO3 that will get bonded to this side. So to this carbon, HSO3 get bonded, and sodium will bonded to this oxygen. After that, there will be exchange between this hydrogen and the sodium. So sodium will go there to the SO3H, and hydrogen will come to OH, oxygen. So this one form here, and that will be a bisulfite addition compound it is, and it is a crystalline solid. Then after this addition of Grignard reagent, that's very easy. I think I have taught you also, but maybe you watch out the other videos. In the other videos, I have explained about the reaction of aldehyde and the ketone with Grignard reagent. But here also we will discuss about the addition reaction of Grignard reagent with aldehyde or with the ketone. There aldehyde or ketone, again the same procedure there will be, same. Yes, product will be different in case of aldehyde and in case of ketone, but class of the compound will be same. Let's see here. First of all, when the Grignard reagent will react with methanol, or that is also called formaldehyde. Of this common name will be formaldehyde, and IPAC name is methanol. This one. A Grignard reagent I am taking ethyl magnesium bromide. Ethyl magnesium bromide. I think who have watched my video seriously by taking the pen and paper, that means if he have watched the video, and in addition to that, by considering that I am in a classroom and by keeping the notebook and the pen, if anyone have watched this video, he will not feel any difficulty. Let's see here how the reaction is taking place. Same, the oxygen will take the pi electron towards itself. So here negative charge, carbon will have positive charge. In the case of Grignard reagent, bond between carbon and magnesium will dissociate, because there is covalent bonding between the carbon and magnesium. So magnesium will be positive, carbon will be the negative. So magnesium, and that will go toward this oxygen, and this alkyl group that will come here to this carbon. So compound will be here. This reaction firstly you will have to do in presence of dry ether. So in presence of dry ether, the formaldehyde or the methanol will react with a Grignard reagent. Here the name of Grignard reagent is ethyl magnesium bromide. So the formaldehyde is reacting with ethyl magnesium bromide, the Grignard reagent. Then firstly this compound will form, and then after pass the water. So water when you will pass, so there will be H plus and OH minus sign. So magnesium that will combine with this OH. So product will be Mg, Br attached here, and OH 2, and the hydrogen that will combine to this oxygen. So compound will be this will be the product. So here is formation of 1 degree alcohol. When the Grignard reagent will be treated with formaldehyde or with the methanol, there will be formation of 1 degree alcohol. When another aldehyde will be taken, then what will happen? Let's see. I am increasing by only 1 carbon. So ethanol I am taking. That is reacting with ethyl magnesium bromide, which is a Grignard reagent, in presence of dry ether. An aldehyde propanol here. no, sorry, an aldehyde ethanol is now reacting with the Grignard reagent ethyl magnesium bromide in presence of dry ether. That means we will take the solvent dry ether, and in that we will react the ethanol with the Grignard reagent ethyl magnesium bromide. So what happened? This oxygen will take pi electron towards itself. So here negative charge, this carbon will have positive charge. And in the Grignard reagent, there is covalent bonding between the carbon and the magnesium. So magnesium is the positive part and carbon here is negative part. That's why magnesium will attack towards this oxygen, and this negatively charged carbon will attack towards this carbon. So what will be the compound here? Firstly that is formed, and then after it will be treated with water. Same in water, that is composed of H plus and the OH minus. Since magnesium is a metal, that means positively charged species, so that will pick the OH minus. So magnesium will combine with this here OH, so the one product will be MgBrOH, and hydrogen will bond to this oxygen. So product will be so what you have watched, that when this aldehyde has been taken, that means other than the aldehyde, other than formaldehyde has been taken, then 2-degree alcohol form. And let's see, when we take a ketone, when we take a ketone here, that's react with ethyl, same type of Grignard reagent we are taking everywhere. So ethyl magnesium bromide. Now we are reacting the propanone with the Grignard reagent ethyl magnesium bromide, and the solvent is dry ether. What is happening here? The oxygen will take the pi electron towards itself. So there will be negative charge on the oxygen and the positive charge on the carbon, because oxygen have taken both the electron. So for the oxygen there is gain of 1 electron. That's why one negative charge has appeared on the oxygen, and for the acylic carbon there is loss of 1 electron. That's why 1 unit positive charge appears there. So now same of the ethyl magnesium bromide, there is covalent bonding between the carbon and the magnesium. So magnesium is the positive part and carbon is the negative part. So positive charge will bond to this negative charge and this negative charge to this positive charge. So product, so what will form here? After that react with water. So of water there is H plus and OH minus, and magnesium here is a metal, so always that will gain the OH minus. So of water the OH will get bonded to the magnesium, so product will be, and the hydrogen of water that will combine to this oxygen, so compound will be So in third case, when we have treated the Grignard reagent, that is ethyl magnesium bromide here, when we treated the ethyl magnesium bromide Grignard reagent with propanone, there is formation of the 3-degree alcohol. So here the conclusion is that the methanol, when methanol will be treated with Grignard reagent and followed by hydrolysis, there will be formation of 1-degree alcohol. The aldehyde other than methanol will give 2 degree alcohol and the ketone will give 3 degree alcohol. When the Grignard reagent will be treated with methanol, there will be formation of primary alcohol with aldehyde other than methanol, the 2 degree alcohol, and with ketone, the 3 degree alcohol will form. Okay, so that is here. That is reaction with Grignard reagent. That when methanol will be treated with the Grignard reagent, there will be formation of 1 degree alcohol. The aldehyde other than methanol will give 2 degree alcohol, while the ketone will give 3 degree alcohol. That was addition of Grignard reagent. Then after is addition of alcohol. Next point here is addition of alcohols. So when the aldehyde will be treated with monohydric alcohol, there will be formation of hemiacetal firstly, and then after there will be formation of acetal. So when the aldehyde will be treated with 1 degree alcohol, there will be formation of firstly the hemiacetal and then after the acetal. The ketone reacts with dihydric alcohol and there will be formation of ketal, K-E-T-L, ketal. About that we discuss here. Let's see. In the book, reactions is in different, but I am telling you in different manner, just like. So what is here? Suppose this is a Grignard reagent. This Grignard reagent that you react with an alcohol, this one. So what happens? This oxygen take the pi electron towards itself. So here negative charge on the oxygen and a positive charge to the carbon. Now alcohol, that will there will be plus and oxygen will have negative charge. So O minus, that will get bonded to the acylic carbon and hydrogen to the oxygen. So compound become this compound is called hemiacetal. So the aldehyde reacts with monohydric alcohol. So firstly there will be formation of hemiacetal, and then after this hemiacetal again react with the another alcohol molecule, then there will be a formation of air. This one will dissociate, and this oxygen will bond, and there will be a formation of that means when two alkoxy group bonded to the carbon, that will be called acetal. In acetal, the two alkoxy group will be bonded to the carbon, and in hemiacetal there will be one alkoxy group and one hydroxyl group will be bonded. Keep in the mind, in hemiacetal one hydroxyl group and one alkoxy group will be bonded to a carbon atom, while in case of acetal the two alkoxy group will be bonded to the carbon atom. So that is acetal. Let's see about the ketal. Ketal here written, not written like that. Okay, watch out here. In case of ketal, I am telling from the book here. So these two hydrogen atom that will combine to this oxygen. So two hydrogen combine to this oxygen, that will form H2O. So the valency of this carbon atom, this oxygen and this oxygen, that will become destabilized. So this oxygen will do single bond formation with this carbon, and this oxygen will also bond to this carbon through single covalent bond. This oxygen will bond to this carbon through single covalent bond, and this oxygen will also bond to this carbon through single covalent bond. So what will happen? And this side is CH2 and CH2. So that means here to this carbon atom, this oxygen is bonded. This oxygen will be bonded through single covalent bond, and this oxygen will also bonded through single covalent bond. So here bonded, and both the oxygen, this oxygen is bonded to this CH2 and this oxygen is bonded to this CH2. So there is a formation of a ring inside. So there will be a closed ring will form. Once again listen. When this hydrogen and this hydrogen combine to this oxygen, form H2O released. So the valency of this oxygen will be unsatisfied and this oxygen will be unsatisfied. So this oxygen will bond to this carbon through single covalent bond, and this oxygen will bond to this carbon through single covalent bond. And already between these two oxygen there is already a ethyl group. So here ethyl group. Between these two oxygen there is ethyl group here. So that's why it is called ethylene glycol ketal. It is a type of ketal, and here its common name, it's not IPAC name, here it is called ethylene glycol ketal. This compound, the compound in which the two OH group present to the same carbon, that is called glycol. The compound in which the two OH group are bonded to the adjacent carbon atom, that is called glycol. So hydrogen of this OH and hydrogen of this OH has been combined to this oxygen and form H2O. So this oxygen will be bonded to this carbon through single covalent bond, and this oxygen will bond to this carbon through single covalent bond. So that single covalent bond and single covalent bond has been formed, and then after CH2 between both of them. So there is a formation of a ring. So the ketone will react with dihydric alcohol, and there will be formation of ketal. Okay. That was next point is the addition of ammonia and its derivative. Let's see here. Firstly, we react in the aldehyde and ketone. Same type of reaction will be there. So I am not writing separately. Here, during the formation of acetal and ketal, there was difference that aldehyde was reacting with the monohydric alcohol, and there was formation of firstly the hemiacetal and then after the acetal, while ketone was reacting with dihydric alcohol and there was formation of ketal. But in case of here will be same. So let's see here the reactions I am doing. H. Any R you can also take here. Whatever be that, this group may vary, this group. As for example, I am taking. And here ammonia. So in ammonia, there is a lone pair of electron at the nitrogen atom. What happened? The oxygen take the pi electron towards itself, so there will be a negative charge on the oxygen and a positive charge to the carbon atom. Then after, since there is a lone pair of electron, so this nitrogen will get bonded to this acylic carbon. So product will be here firstly during this course, nitrogen have given one electron to the carbon and through other electron it has done bond formation. So for the nitrogen there is loss of one electron and here was positive. So when one electron came to this carbon, so that positive charge will disappear. Then here because there was deficiency of one electron, positive charge means deficiency of one electron and one electron from the nitrogen has came here. So that positive charge will disappear and a positive charge will be at the nitrogen. Then after, since there is the positive charge on the nitrogen, so it will attract any one of the sigma electron of NH bond. So it will release as H plus ion and this H plus ion will bond to this oxygen. So product will be now here is a lone pair of electron on the nitrogen atom. So what happens? This lone pair of electron will come here. This lone pair of electron will come here for the double bond formation. So there will be again positive charge to the nitrogen. So what will be? Positive charge to the nitrogen and here H or R. After that, since there is a positive charge on the nitrogen, so this nitrogen will attract any one of the sigma electron of NH bond. So this H plus released from here, that H plus released will combine with OH minus. That H plus released. So here, then after, there will be H plus ion here, that is this H plus ion released, that will combine with this OH minus and form H2. So here will be, there is already double bond, here double bond. So compound will be here, this structure will be CH3, CH2. Okay, here I am touching this here. Here I am informing you. This OH here, hydrogen and R. And here is double bond, nitrogen, here H and H plus will release. So H plus will release here. This H plus will combine to this OH and here also valency of this one will become destabilized. So that's why this H plus released. This H plus will release. Okay, listen here separately. Goes on the here this one. H plus, this nitrogen will attract the sigma electron of this NH bond. So H plus will combine with this OH and form H2. So product will be when there will be double bond between the carbon and nitrogen, that compound will be called imine. So in this case, there will be formation of imine. When you have reacted the aldehyde or the ketone with the ammonia, there will be formation of imine. Imine is the compound in which there will be double bond between the carbon and the nitrogen. Then after is when you react with amine, This one react with amine. So what happen? The oxygen will take the pi electron towards itself. So oxygen will have negative charge. The carbon will have positive charge. Then after here, at the amine, there is also a lone pair of electron at the nitrogen atom. So this nitrogen that will be bonded to this carbon. So compound become why here positive charge? Because this nitrogen will donate one electron to this positively charged carbon, and through other electron it will do bond formation. So when this carbon will gain one electron, then the positive charge will disappear, but there is loss of one electron for this nitrogen, so a positive charge will appear on the nitrogen. So here this compound form. After that, this nitrogen take the shared sigma electron of this NH bond. So again there will be lone pair of electron and positive charge will disappear, because when the two electron will come to this nitrogen, of which one electron is of only nitrogen and one electron is of hydrogen. That's why two electron will come to this nitrogen. So that's here positive charge will disappear. This H plus will combine there and that become OH. The H plus ion released from here, that has been taken the electron here, and the H plus ion released from here, that has been combined to this OH, oxygen. So that converted to OH, and this one. Now again lone pair of electron here, but reaction will not stop here. Here reaction will not stop, because the lone pair of electron present at the nitrogen will not let the reactions to be here only. So what happened? The lone pair of electron will come here for the double bond formation. So there will be double bond between this nitrogen and this carbon, and the H plus ion release that will combine with this OH. So that okay, firstly goes watch out here. So here firstly there will be double bond formation here, and the H plus from here, this H plus released, that will combine to this OH and form H2O. And here is R. Oh. This one. When there will be a compound here, there will be double bond between carbon and nitrogen, and any alkyl group or any whatever be that, alkyl, aryl or any group will be bonded here. So that is called Schiff's base. When there will be here that was forming here, so this will be called Schiff's base. Okay. When there will be double bond between carbon and nitrogen, and an alkyl group will be bonded to the nitrogen, then the compound will be called Schiff's base. Okay. Now another one is reaction with hydroxylamine. This is called hydroxylamine. This compound is called hydroxylamine because in this compound there is OH and NH2. That is amino group and the hydroxyl group both is present in there. So that's why this compound is called hydroxylamine. Same procedure as we have done earlier. Same procedure will be here also. Because there is lone preferred electron at the nitrogen. So oxygen will take electron here for negative charge, here positive charge. So this nitrogen will come to this carbon. So compound become recall. Why positive charge has appeared at the nitrogen? Because the nitrogen have donated one electron to this positively charged carbon, and through other electron it has done bond formation. So there is loss of one electron for this nitrogen. So that's why 1 unit positive charge has appeared on this nitrogen. Then after, this nitrogen will take the electron here, sigma electron. So this H plus here released, this H plus released, that will combine to this oxygen. So that become OH. So product will be here. Will the reaction stop? No, there is a lone pair of electron at the nitrogen. So here is the lone pair of electron. This will come here for the double bond formation. So that time again positive charge will appear on the nitrogen, and this positive charge. So the here H plus release, that will combine with this OH will form H2O. So what will be there? This one here to this nitrogen that is doing double bond formation with the carbon and OH here. So this compound is called oxygen. This compound is called oxygen. This is a type of oxygen. What was Schiff's base? When nitrogen was doing double bond formation with the carbon, and that was also bonded to, that means that carbon nitrogen from one side bonded to the alkyl group, and to the other side it was bonded to the other carbon atom through double bond. So that was called Schiff's base. Here it's called, here nitrogen is bonded to one OH and through the carbon atom through double bond. So this is called oxygen. In this compound, nitrogen is bonded to one side to OH and to the other to the carbon through double bond. That's why this compound will be called oxygen. Okay. Now let's see reaction with hydrogen. Guys, what happened? A number of students watched the reactions about which I am doing here by reacting. In the IIT main question, when they appear in the IIT main examination, they find out that there is a reactions. But what is actually here? When about this chapter, the reactions was they will observe about which we have discussed right now. But since that is here in the form of this one and it has been not explained, that's why they think that the questions don't ask from the NCERT. That means to crack the IIT main, they don't consider the NCERT book as a sufficient. But the 90% questions asked only from the NCERT book. When you will study the NCERT book by understanding, then you could solve 90% questions. I reiterate, when you will study the NCERT book by understanding, then you could solve more than 90% questions. of IIT main, and in NEET examination, what that here among out of 45 you could solve 42, 43. Okay, here let's see. So this one it is called hydrazine. Same here, same process. Nitrogen lone pair electron. Here oxygen will take pi electron, and here positive charge. So this nitrogen will come here. Along with that, NH2 will lie together. Now what happened? There will be positive charge. So the nitrogen will take any of the sigma electron towards itself. So this hydrogen will compound to this oxygen. So what will be there? Here H or R here. Here again lone pair of electron. This lone pair of electron come here for the double bond formation. So there will be positive charge to the nitrogen. To neutralize this positive charge, it will take any one of the sigma electron from this side. So this hydrogen released, that will combine to this OH. So this hydrogen will combine with this OH. So form H2O. So there will be double bond formation between this carbon and this nitrogen. Here is NH2. This product I am writing here. Here I am writing. This one here. It is called, here which hydrogen it has been reacted. So that is called, this compound is called hydrazone. Okay guys, very simple. Now a number of reactions we have done. So the other one, that means with aldehyde and with the ketone, you react the remaining one. Till here I have discussed here about this one, about when, that means the reactant here. This one reactant is derivative. So with this one you do by yourself. These three you do by yourself. This one I did. That means reaction with hydrazine till here I have completed. Now with phenyl hydrazine you do at your home, and these three that you do by yourself. Okay, you could solve this one very easily. So remaining questions, remaining reactions we will discuss in the next class. It's all for the today class. Thank you, Team Magipet.